Hi, there's Professor Monte. Let's look at solving rational inequalities using a sign chart. This problem is a little bit harder. I did another video where the problem wasn't quite as hard. I'll link that to the end of this if you want a little simpler version, but this is a little bit harder. Okay, and I've got the steps. I'll go over them real quick because I've gone over them with rational inequalities and with polynomial inequalities already in my earlier videos. But the steps are we need to set it equal to 0. We need to factor if needed. We need to find where each factor equals 0. Those are called our critical values. Put all critical values on a number line. Check a test number between and outside each critical value to see if it's positive or negative. And then if we're looking for where the function is less than 0, that means negative numbers. And if we're looking for where the function is greater than 0, that means positive numbers. Remember, with rational functions, rational inequalities, even if you have the less than or equal to or the greater than or equal to, you can't keep any number that makes the denominator 0. All right, so let's go through this problem using these steps to see how it works. All right, the first thing I notice is I've got this rational inequality, but it doesn't have 0 on that side. I need that to be 0. A big common mistake I've seen a lot of people do is they'll say, oh, multiply both sides of the inequality by x plus 5. We can never multiply both sides of an inequality by an x because sometimes, in this case, x plus 5 is positive and sometimes it's negative. Why does that matter? Well, because if it's negative, we flip the inequality. So if I'm multiplying by x plus 5, some of the times, for some values of x, I flip the inequality. For some values of x, I don't flip the inequality. So I have to get that 1 over on the other side first. So I need to get this set equal to 0, so I'm going to subtract 1 from both sides. It's going to look like this. Kind of ugly. It's x minus 3 over x plus 5 minus 1 is greater than or equal to 0. Now I need to get that to be a fraction, a single fraction, so I'm going to get a common denominator. I'm going to multiply this by x plus 5 over x plus 5. And so now what I have is x minus 3 over x plus 5 minus x plus 5 over x plus 5 greater than or equal to 0. Distributing that, I've got x minus 3 minus x minus 5 over x plus 5 greater than or equal to 0. Or, notice these x's cancel. I just get negative 8 over x plus 5 greater than or equal to 0. All right. Now, notice, I usually set the top equal to 0 and the bottom equal to 0. Well, that never equals 0. That doesn't give me a critical value. Well, this does. If I subtract 5, I get x equals negative 5. That's my only critical value. So when I go to my sign chart, I'm going to go negative 5. I'm going to plug it into both of these. Negative 8 and x plus 5. And then down here is going to be negative 8 divided by x plus 5. And what I'm going to do is I'm going to test a number. A number to the left of negative 5 may be negative 6, negative 10, something. And a number to the right of negative 5, maybe negative 4. I'm going to plug in 0 because I can. It just has to be any number to the right of negative 5. These are my test numbers. I plug them in here. Well, negative 8 doesn't matter what number I have here. Negative 8 is always negative. I can put negative for whatever. But if I plug in negative 6 here, negative 6 plus 5 is negative 1. And 0 plus 5 is positive 5. Again, I just need the signs. When I divide these, I get a negative divided by a negative, which is a positive, and a negative divided by a positive, which is a negative. Again, let's go to where I have the 0. I'm looking for, well, we'll go here. I'm looking for greater than 0, so I'm looking for anything positive. If it said less than 0, I'd look for the negatives. Well, it's positive over here. And so that's the interval of numbers that makes this original inequality true. Well, that's negative infinity all the way to negative 5. And can I keep the 5? You may say, well, yeah, you can keep the 5%. Professor Monte, there's an equal there. But notice if I plug in negative 5 here, it's negative 8 divided by 0. That's not equal to 0. That's undefined. So even though I have the equal there, I can't keep it because it made the denominator 0. So that's my answer. You may kind of check by saying, okay, let me plug in a number in here, maybe -6, into the original problem, see if it's true. Well, -6 minus 3 is -9. -6 plus 5 is -1, which is +9. Is that greater than or equal to 1? Yes, it is. So a number in there worked. That looks hopeful. And let's check a number not in there, maybe -4. Well, -4 is going to give me a -7 over +1, which is -7, which isn't greater than or equal to 1. So it doesn't work. 0 would have been real easy because I plug in 0 and I get -3/5. Oh yeah, that's not greater than or equal to 1. So a number outside of the interval didn't work. That didn't prove that this works, but it's looking pretty good. That probably is the right answer. All right, hopefully that helped. Again, like always, practice and you'll get better.